We are now going to do graph intervals on a number line. Most of you are familiar with graphing numbers on a number line. As an example, you might draw a simple number line, and if you were asked to plot points on this number line, you would typically start with the normal numbers, 1, 2, 3, 0, and the other integers, -1, -2, and -3. Fairly common for us. And if you were asked to plot the point 3 on the number line, you would typically just put a dot, solid dot, at the number 3, and that represents the number 3 on the number line. What we want to look at are how do we graph intervals on the number line, so that we're talking about things other than if we were to say x equals 3, which is what this particular number line would represent. How would we graph something like x is greater than 3 on a number line? That number line would set up very much the same. We'd still put our integers down that we typically do, -3, -2, -1, 0, 1, 2, and 3. But now if we wanted to get all those numbers that are greater than 3, we now look at not including the number 3, so we use what's called an open circle to represent that, as opposed to the equal to 3 that we did in the above graph. And we would shade, because our variable is on the left-hand side, it helps us to see this, we would shade everything pointing to the right. So that would shade this whole direction, and it would be all the numbers that go in the green arrow direction, which would be greater than 3. When we write that as an interval, it looks a little bit different, probably a little different than what you've seen before. We have this thing called an interval, and what that interval means is this. We're starting at the number 3. We're not including the number 3, so what we do is we put a parenthesis around that. Then we say, how far is this number going? Well, in this case, this number is going as far as we can take it, or to a number that we would call infinity. And we do that kind of sideways 8 that represents the number infinity. This right here represents the interval from 3 to infinity. This is the graph of that interval, and this is what the inequality looks like. Let's do another one. What if I wanted to do x is less than or equal to 1? Well, we would put our number line down, the typical one that we're used to making, with the usual integers. And I'll show you a shortcut for this in just a second. So here are our typical integers. Now if we want to write this one as an interval, notice we have the equals to as well. So when we go to graph that one, we're going to have a solid circle at the number 1 because we include that number. But now again, because our variable is on the left-hand side and our inequality is pointing to the left, referring to less than, the numbers that are smaller than, we know that that's going to give us all of these numbers to the left. And it will go as far as we can take that. How do we write that as an interval? We would write that, well, we're way out here to the left, and that continues on indefinitely, so we would say that goes from -infinity, way out, as big a number as you can think of to the left, all the way up to the number 1. But because we're including the number 1 this time, we put a bracket around that. And that represents the interval from -infinity up to 1 and including the number 1. So you can see that's how we look at some of these different intervals. Let's do another one. Slide up our screen a little bit. What if I had x greater than or equal to a -2? Again, typical number line that we would draw. We start at 0. We typically put down our integers, the most common ones. And now what we're looking at is we're including the number -2. So we're going to put a closed circle on the -2. Our variable's on the left. It's pointing to the right, meaning we're greater than -2, which those numbers are to the right on the number line. And that would give us all these numbers, and it would continue on indefinitely as far as we could take it. And so that interval would look like we're starting at -2 and including it, and we're going as far as it'll possibly go, which means it will go to infinity. But we can never actually reach that number infinity. That's why we put the parenthesis around it, because we never actually get to it. Because for every number you can think of, we can always think of one bigger. But that would be the interval from -2 to infinity on this particular number line. Now there's got to be a shortcut, a better way to write this, so we don't have to keep putting down all these numbers. And there is. Let's try one like this. What if I had to do x is less than 14? Well, I certainly don't want to write a number line that goes all the way out to 14. So a way to indicate that is this. We draw our number line. And to do it in a little bit quicker fashion, I know 14 is right here. Doesn't really matter. I can put 0 right here. I'm not going to put all the little tick marks in between. But here's what I can now do. I'm starting at the number 14, but I'm not equal to it. So because of that, I'll put an open circle. My variable is on the left-hand side. My inequality is pointing to the left in this case, which means I want all the numbers smaller, or to the left on the number line, which means I'm going to have all of these numbers like this. And my interval now, hopefully you can be thinking ahead of me on this, would be from -infinity. We're coming all the way up to the number 14, but we're not including the number 14. And so that interval would be from -infinity to 14. So that's what your intervals look like. We can also run intervals that go from one number to the next. What if, in my particular inequality, I end up with one that looks like this? I've got the number 2, it's less than or equal to an x, and it's less than or equal to the number 9, which means I want the numbers that are somewhere between 2 and 9 and could be equal to 2 and 9. When I make my number line, I'm simply going to put the two endpoints down. I know I'm at the number 2. I know I'm at the number 9. Notice when I arrange them, 2 is smaller, so it's to the left of 9 on the number line. 9 is greater, so it's to the right on the number line of the 2. I'm including both of them, which means in this case I would have closed circles on both of these, closed circles on both of these. I would be shading everything in between, and that interval, since it's including those numbers, would look like this. I start at the number 2, I go and keep moving until I get to the number 9, and then I'm going to put a bracket around that, which means I'm going to be including the number 9 in this particular interval. Okay? So this is what intervals and interval notation looks like.